Hey everyone, thank you. Really thankful for you guys to come so early in the morning. Personally, I don't wake up for a few more minutes usually, so I'm sorry if I'm a little tired, but it should be okay. So yeah, today we're going to talk distributed GraphQL schemas. If you're even new to the community or pretty old to the community, you've heard about distributing your schemas, and you've heard the hype around microservices and GraphQL being the new savior to publish your APIs in a microservice architecture. So we're going to talk about this today. So I'm Mark, you can call me Mark. I work at GitHub, and I'm from Montreal. So usually I put a slide of Canada, like something with snow, but I think we're all familiar here. So what do we mean by distributed GraphQL? To me, this always sounded funny because the company who invented GraphQL for their own use case was probably the best example we have of a big monolithic app, right, at Facebook. So I was always like kind of curious on why people immediately jump to GraphQL by saying it's the new best thing for microservices, joining different sources, different use cases through one graph. So in the past few months, I've been really looking into what we actually want from GraphQL and if it's the best fit for our distributed architectures, or maybe it isn't. So our straightforward, like typical GraphQL implementation looks like we have a single GraphQL API, and we respond to queries. With a microservice architecture or a little bit more distributed architecture, we've got a few advantages that people really want to get, right? We've heard about them. If you heard about people talking about microservices in general, besides GraphQL, right? We want to be able to develop on a certain use case independently. We want to be able to scale that independently. We want our whole application to be available even if one part falls apart. We want really strong boundaries. It's a really important one. We don't want implementation details from one of our services or use cases to leak into other things. And there's a lot of other reasons, right? So obviously when GraphQL was released, a lot of people thought this could be a good fit, right? And we saw people wanting a use case that looks a little bit more like this, having a bunch of schemas, and somehow when we send a query to them, it gets resolved in some way. And today we're kind of going to talk about what these ways are to achieve that, and if it's truly what we're looking for in GraphQL. We won't talk too much about how to split a schema on a single monolithic app, like if you've heard about GraphQL modules, code organization tools. We're really going to talk about what happens when we divide our schema across the network. So in the past few years and months since GraphQL was publicly released, we've seen a lot of solutions. If you're new to the community, you might have been confused on what to use, right? We had schema stitching being really popular. It's still pretty popular. Schema federation is a new term we hear often. Schema modules, what we were talking earlier, dividing your schema, maybe even in the same app. Schema composition, which is another new word we've heard recently. Namespaces is a big one. People are wanting namespaces for similar reasons. And GraphQL gateway, GraphQL being our new king API gateway, right? And even recently, Apollo released principled GraphQL. I don't know if you've all seen that. It was kind of similar to the 12-factor app thing where they had like 12 rules for a great GraphQL API. And two of the rules were a GraphQL API should expose one graph, so like one exposed schema for API clients. And the second one was this one graph should be implemented in a federated way, so your schema should be distributed. So when I read that with what I was saying earlier about Facebook, who invented it, who has like the biggest monolithic app, I was like, there's something I'm maybe not getting here because it seems to be two pretty different implementations. So at GitHub, we've recently been extracting things a little bit. People are starting to build new services instead of our giant monolithic Rails app. So we had to start thinking about what this would look like for a public API because we didn't want our clients to be calling a certain service for certain things and another service for certain other things, especially with a one graph thing that GraphQL kind of offer. So I asked myself, is this the only way going forward? Do I have to use either schema stitching, schema composition? I was a little scared because we do hear about it a lot, but we don't see actually a lot being used in production and what can go wrong. So I've been really looking into this, and I'm pretty happy to talk about you, like kind of the spots where I'm not sure and the spots that I really liked. So maybe it's the future. I don't know. In this talk, we'll have probably a lot of maybe unpopular opinion or opinions that you've not heard so much recently. It might be the solution, and we'll discover that. But first, a little bit of history. Why are we here today? Why is GraphQL so popular? Why was it invented in the first place? And I always like to start back when GraphQL wasn't even there, and most APIs were done using endpoint-based APIs. And in that, I include REST APIs, HTTP APIs, anything that's endpoint-based. And they were actually pretty great, right? Endpoint-based APIs are really, I've actually liked them more now that I use GraphQL a lot because it's so great to have one use case solved by one endpoint. It's super easily cacheable, and usually provide, if you're using REST, provide links to related resources. It's pretty cool when it works well. There's one thing though, the really great thing about really optimized for one use case can fall apart pretty quickly sometimes, right? Because at first when we had an API, we had maybe like web browsers and mobile. These days, when you have an API, your clients, you have a lot of other servers, gaming consoles, an analytics job maybe that's running, that's querying your API, internal services querying your API, and even your fridge probably now, Samsung, is calling your APIs. So that one endpoint for one use case is not really fitting what we see right now, right? Each client, your fridge or another internal service calling your API, might have a totally different use case or slightly different data requirement. Maybe we don't actually want to send a huge payload to your fridge because it's running not on LTE, or who knows. Every single client has different data requirement. And a lot of people struggled with that. And a few different solutions were tried, right? I had an API, a planets API like this, with a very optimized get planets that returns mostly the good thing in most cases. That works well. But if my fridge needs just the name of the planet and something else, well, some people tried I'll create an endpoint per use case. But you can imagine how that kind of explodes really quickly. So there's the idea of like partials where you could say, oh, give me the minimal version of this endpoint, minimal representation of this endpoint. Maybe I have a query parameter like, oh, this is the PlayStation version that I want. All of these kind of explode pretty quickly too. And then we've had some APIs reinvent kind of a query language in a query strings. It started with that fields argument, give me just the name and population. And then eventually it can give that you're reinventing GraphQL inside an endpoint-based API. And you can also use, some APIs use accept headers to change kind of which representation you get of the resource. So GraphQL was not the first solution to this. A lot of people tried to solve that problem because everybody hit these problems. So 6 years ago at Netflix, they did something really interesting to solve that problem. They had I don't remember how much, but hundreds of different clients. PlayStations, Rokus, just everything that runs Netflix. So they definitely hit that problem. And what they did is, I really encourage everyone to read that blog post, is they have this concept of server adapters, client-specific server adapters, that they can plug in their API that just will, before the response goes back to the client, will run client-specific code to filter out unneeded fields, maybe do an extra call to fetch information that a PlayStation needs, but not an Xbox. And if you read the blog post, it's really interesting. It has worked pretty well for them. So that's one approach to, we don't want to actually have 100 endpoints for everything, but we have some kind of system to adapt payloads to each use case. 6 years ago at SoundCloud, also, people were hitting the same problem. They had a distributed architecture already, have a bunch of service, and at first they had an API gateway, but that API gateway was trying to answer different requirements from mobile, from web, from other clients. So what they tried is splitting that API gateway in what the pattern is now called a backend for frontend. So where each gateway, so call it BFF, mobile and web, serves specific use case. So you would build one gateway per use case. And that's also a way to architect something that will answer different client needs. You can see how even this, though, could build up to having like a lot of gateways here. But that's one great way, and it's still used by a lot of companies to this day. This pattern is really great. So 6 years ago, where was Facebook? Were they thinking about something? Well, yes, in the same years, 2012, Facebook was trying to think about GraphQL. So to me, GraphQL is kind of a backend for frontend, really. It's kind of a really, really smart backend for frontend, where you don't need many, one per use case. You actually have an engine that will kind of modify your use case for you. It's how I kind of see GraphQL. And GraphQL is also kind of a client-based adapter thing from Netflix, where the GraphQL specification, your library that you're using, the engine, is kind of acting as that client-specific modifier. So I think by keeping this in mind, by learning where we're coming from and what other solutions were created for this, we can really start to understand what GraphQL is really like, what we really want to use it for. So let's start by actually talking about distributed schemas. And let's start by schema stitching. I would say that's probably the most popular one. Is anybody using schema stitching in the room? Cool, so I have a few people. It's probably the most popular way of distributing GraphQL schema. It was popularized pretty much since the beginnings. And this is what it looks like if you've never seen it. So let's say we have a film service and a character service. It's a very simplified example. The film service can return all the films. A film has a name. The character service, you can query a character by ID, and a character has a name. And this is what schema stitching will do is just merge these two schemas into one. And in this simplified example, there's no conflicts, there's nothing. You can just merge everything on a query root here, and the types can live together. So that's great. Where it gets trickier is when the film service here, the film should have characters. But if you see here, the character type is not actually in the film service, and on the other side, where a character has films, the film type that it's returning is not in the character service. So with schema stitching, they had to find a solution to this where how can we make sure that the type will become available when the schema is finally stitched? We don't know. Each of these schemas are individually invalid, so it's hard to test locally. You can't even boot up a GraphQL API with one of these schemas. So there was two options, and it's two options you see in some APIs in production right now. The first was to say, you know what, we won't use types that belong to another schema. We'll just replace these by ID references. So instead of this here, we'll do this. So a film instead is a character IDs. And we can, using these IDs, we can fetch the characters in the other schema. And you see here, there's no type in a film service that doesn't belong to the film service, and there's no type in a character service like this either. So that works. However, I always found it kind of weird that we like GraphQL because it allows us to navigate relationships, expand relationships, query them, and now we've basically just removed that, and we just return IDs for you to request for a next query. So what I've seen before, companies have chosen this approach is they'll have like a field where it's going to be select film and characters for this ID and try to load as many things as possible at the same time. The other part is, if I go back to here, the schema design, and if you can imagine a very large schema like this, is just we've limited our clients a lot compared to if we actually had something like this working. So to me, this is really not an ideal. If I had to do it at GitHub, I would never choose an approach like this because I feel we're leaking the fact that we have trouble linking our types together and just provide a poor schema to our clients. So the second option that's schema stitching, and this one is probably the most popular, is to, instead of including the relationships in each of the schema, we're gonna strip them away. And then we're gonna have something called links or relations. Probably depends on which library you're using to do schema stitching. But these links are gonna be individually appended at the gateway level. So remember we had like this one gateway that tried to merge a bunch of schemas. So that's kind of the equation of schema stitching is we're gonna merge our schemas together. They have nothing in conflict usually. And then we're gonna merge links. So everything we wanna connect between these two schemas after. So this would give, finally this would give a schema like this, which is valid. And yeah, the extent here instead of type is probably a little less known, but you can use that to extend a pre-declared type, which is pretty cool. So this is kind of what it looks like. We've got a gateway that contains the final schema, but also has defined the links, and the services define their own schema without any relationships. So what happened here? Did we actually decentralize what we really wanted to do, where each schema is really independent? Or are we actually kind of centralized again, because really everything that's linking everything together is in one place? Imagine we want to add something new, maybe adding a new type to the character service. If it's actually used by any other part of schema, I also need to go ahead and maybe do a PR on the gateway. And then which one do I merge first? What does the development experience look like? It's usually kind of a two-step thing to get something into production. And to me, that's probably not what we were looking for when we were trying to find like a really great distributed architecture for GraphQL. So it's really not clear to me if that's the right approach because of these reasons. And the last point here is, where does one even add new functionality here? I'd be really worried that because linking is so difficult at the service level, people start adding functionality directly in the relationships at the gateway level. And now we've just got a monolithic schema really again. So this is a little scary to me. And I'm not the only one who thinks like that. This is a Twitter thread that was pretty recent that I really like and I agree. And even the author of Schema Stitching, Mikhail, was a great member of the community who invented stitching in the first place at first, says he doesn't like it anymore. And we've talked about this before with him, and we're kind of thinking the same here. So I'm a little careful with schema stitching. I think it can be really useful, but I do have these concerns. But what should an API gateway even do, right? And maybe what's even more important is what it should not do. Here we saw that we tend to put a lot of logic on the gateway because it's hard to actually decentralize things. So the goal of an API gateway, try to like summarize it in one sentence, is to decouple clients from the services involved in the use cases they're consuming. So we don't want to leak if there's 20 services actually resolving one field. Clients don't care about that. And the first thing I really want to avoid when thinking about a gateway is business logic starting to leak in that gateway, as we talked earlier. And this is a really common thing with API gateways. You start off as just maybe being a little proxying to your services, and then a few years later, everyone's just doing PRs on the gateway because services don't matter anymore. So I'm always trying to avoid this scenario when I'm thinking about building a gateway. And of course, we want to avoid having a single point of failure because we have a distributed architecture, we love it, we wanted to expose it as a public API. We don't want to go back to being just a monolithic API gateway. And you take care of that by using whatever means of making your API gateway available. which we're not going to talk about in this talk. That's for another talk. But it's still very important. And I don't know if anyone's ever read the ThoughtWorks Radar. This is a really cool article. They usually post their radar that's on a bunch of technologies, and they say, should you use it, should you hold? It's really interesting. And I really, really liked what they said about API gateways in general. And that's not, we have API gateways for REST, for a lot of things. But this is really awesome. They said, we remain concerned about business logic and process orchestration implemented in middleware, blah, blah, blah. Vendors in the highly competitive API gateway market are continuing this trend by adding features through which they attempt to differentiate their products. This results in an over-ambitious API gateway. And this, what I was talking earlier, I'm really scared that these technologies, for GraphQL specifically, will try to include a lot of features at the gateway level, and we'll lose what the goal we wanted in the first place. So I think we got to be careful of that. But what about that new schema composition or federation approach? This is more recent, it's maybe this year, where people realized maybe stitching, because of these reasons, was not perfect. And basically, what people say when they say schema composition is where we don't have these links at the gateway level anymore. We want the schemas at that service to be completely independent and to form a graph without the help of like some orchestrator anywhere in the end. And how it works is, as you see, they're still using the extend. So the film service is extending a type that's not in the service, and the character service extending a type that's not in the service. So in isolation, these schemas are not valid. But schema composition doesn't care about that because it assumes it will always be ran in the context at runtime of other schemas to form a valid schema. So yeah, it's basically schema stitching without the links. In the microservices world, we often talk about choreography versus orchestration. Orchestration being there's some entity that will control a workflow, where choreography is maybe using an event approach. Services will be able to react to each other without the need of an orchestrator. So in this approach, if we go back here, the gateway that would merge these schemas together actually doesn't do much for the schema. It just brings everything together and then controls at the runtime. There's a few things that worry me with this approach too. The first one we saw is the type dependencies we create and how everything needs to be perfect when everything gets merged together. If we're missing any part of the schema, we saw that the individual schemas are invalid. So this is really scary to me. Just thinking about our schema at GitHub, it's really, really giant, and I imagine using an approach like this right now would be operationally very difficult to achieve. The testing and development story are also really interesting. I know that Apollo is probably working on something like this right now. For development and testing with this approach, you absolutely need to run either mocks or a development version of the whole schema because your service in isolation is just invalid. So I'm really looking forward to hearing more about how we can make this better. For now, though, if I was going to choose something for GitHub, this approach just seems very hard to achieve at scale with a lot of services with a giant schema. And then another really scary thing with this approach is who's in charge of the query plan. So with schema composition, usually at the gateway level, we're going to build some kind of query plan. So for this field, you go to this service, then you use this other field to resolve the inner selection. And this is kind of a black box, right? And avoiding N+1s, performance problems, taking down other service breakers, that's going to be a whole really hard area of it. But it doesn't mean it's invalid. I think we need to look more into this approach. I think it makes more sense than schema stitching because things are actually distributed correctly. And in the end, it's really a trade-off between development and operational complexity. If you have one giant GraphQL schema like we do at GitHub, at some point, development gets maybe a little slower, things are a little less isolated, But with this approach, development is great at the service level, but the operational complexity running this thing in production is insanely high. So for us at GitHub, using tooling, best practices, reviews, one giant schema has actually been much easier to run than if I imagine us switching to something like this operationally, where it will be really scary. So I worry about technologies influencing people to split up their schemas too early. Especially if you have one single app right now, I wouldn't go away and try to split that up in different GraphQL schemas. I would actually focus on, if your schema is getting big, try to focus on building better tools for your developers, better best practices. It takes a while before I think it's unmanageable. Even our schema at GitHub is really huge, right? And we really didn't have that much problems with development yet. This might happen though, in that case, we'll look into something else. I worry about splitting too early too, because as we talked about earlier, I really see GraphQL as our portal to use cases, as our backend for frontend, our kind of a dynamic adapter. I wouldn't want to try to map my schema too much to the internal services. So even if you were to split the schema, I'm not sure if I would split it in my current service, how they're organized. Maybe I would create two new like BFFs, GraphQL BFFs that actually respond to certain use cases. So if I have a film and a character service, I don't know if I want to split my schema in film or service. Maybe it's just a film API, and I just want a GraphQL API that transparently calls both services. So in terms of schema design, I'm worried if we try to split too early and map too much to our internal representation, we won't actually focus on answering use cases, and just we'll focus on building a schema that looks like our domain, but maybe doesn't answer real use cases. So takeaways from this talk. GraphQL does seem like a great fit to expose an API, to decouple them from the services behind, and decouple them from your distributed architecture. It's not clear to me that we really need to split up or use a federated approach to be successful in running a GraphQL API. I would use GraphQL as your special purpose backend for frontend. So something that allows your clients to consume use case easily. So don't be afraid to provide different ways to consume use cases on the same GraphQL API. That's okay. Don't try to build the perfect one-size-fits-all API. That's what we were doing with endpoint-based APIs earlier. And this led to problems. So really, don't be afraid to expose different ways of doing the same thing at your gateway level. But make it as thin as possible would be my recommendation. So we talked about earlier, the biggest challenge in API gateway is that lots of business logic goes into the gateway. So try to keep the actual logic of the resolvers outside the gateway. In an ideal world, I kind of see a GraphQL gateway as almost just a schema that knows how to resolve using internal services. Don't put too much authorization in there. Try to delay that as far as possible into your services. So really ask yourself if your GraphQL API itself needs to be split up, or the API can just be one of your microservices, really. Chances are you might not need it yet, as we talked earlier. We haven't needed it just yet at GitHub. We are exploring it, though, because we're getting at a size where maybe it makes sense. But it's always funny to me because I think companies and people who would need to distribute their schemas the most would be the most scared of doing it because of the operational costs. So it's kind of a tricky situation where people who don't need it usually do it, and people who would need it have a hard time doing it. And yeah, as I was saying earlier, consider splitting your schema, if you do, in larger chunks that represent use cases instead of a schema that represents one service. Definitely keep an eye out, and I really want to say that the schema composition talk at the summit this year by Apollo was really great and really inspiring. we would not be ready to jump into that at GitHub right now, but it's definitely a solution I can see working eventually if we can manage this operational cost. Thanks a lot, and I look forward to seeing all other talks today.